Now we will quickly see how all this can be done also in Excel. But before we do that, check out the last line of the code in our R script, this starting write.table. This is a command that enables you to create a dataset of your chosen name from any data that you currently have loaded in R. So it is almost like a reverse command to read.table that we use regularly at the beginning of our work. Now, this write.table command may be useful if you want to export data from R in a specific format, or data that you have somehow processed in R into a format that you can then use with a different software. In our case, we will want to change the data that we have loaded into R so that we can directly work with it in Excel. And the reason why I want a different data set is that here the data that we have loaded into R have decimal commas rather than dots. But since I'm lazy and my Excel is set for decimal dots, I want to create a new data set rather than having to change the settings of my Excel. So now I will take the data set that I have here in R, staff_data, I will export it using the command write.table. I will create a new dataset in my working directory called class 10 dataset staff and at the end _dot.txt. So this will be the name of my new file. I specify in the options that dot is my decimal separator, that the columns of the data or the individual variables are separated with a tab or with a tab separator, tabulator separator, which, as you may remember, is signified with this \NT. And I will also add one more option. I will set the row names command, or the row names option rather, equal to false, because otherwise we would get one column of consequently increasing numbers in our data, which will be completely useless. So if I use this command, I've just now created a new data set with these properties, which I will now load into Excel. So now let's have a look at what we do here. So let's import data. Let's import the newly created data set called class 10 dataset staff.txt. So we use the familiar procedure under the data ribbon here and the label from text. And we have the newly created data set. And we will use the options delimited here and the tab. And that should be it. Okay, here we are, our dataset loaded in Excel. Now once again, we will only work with variables population and staff n. So we can make a bit more space by shifting the rest of the data somewhere to the right using the keyboard combination Ctrl and plus. So Ctrl pressed together with plus inserts new empty columns of data here. We could also just delete the other variables now because we will not need them. Now, we know we want to analyze logarithms of these two variables, population and staff, rather than the variables as such. So we will first need to create the logarithms. In Excel, decadic logarithm, which I have used previously, so logarithm of base 10, is created using the command, well, log10. And in brackets, the original number of which we are taking the log. So in this F column, we will type equal log10, and then in brackets, C2. So this will take the decadic logarithm of 20. We can copy the command across all the cases or across all the countries. So we have just created a new variable and we will call it log staff n. Now we will want to do the same with population. So again, equal log 10 bracket and the values of population. And we can check, by the way, let's call it log population. And we can check that, for instance, Czech Republic should have log around 7, which is 10 to the power of 7. So 10 million, right? So indeed, the logarithm works as we would expect. On the contrary, countries like China should have something around 9, right? Okay, so China 9.1. So now we have our data ready. And now we will perform the regression analysis. And to do that, we go to the data ribbon again and to our favorite data analysis tool pack. So let's open it. And here we will find regression. If we open the menu, we had a set of options. And we will want to insert into these fields the right data. So first, we will input into the input y range the data for the dependent variable, so log of staff n. So this is f2 to f130, right? Now, to the x range, to the input x range, which is the independent variable, we want to input the data for the population size, but the logarithm. So g2 to g130 it will probably be, yes, indeed. So this is the basic setup for the regression in Excel. If we would also like to get a scatter plot with the line as we did in R, we can just tick this option line fit plot. And if we would also like to see the residuals from my analysis or from our analysis, we tick also the residuals plot. And we should get the results on a new worksheet. So this is why I hate Microsoft. So let's do it quickly again. Import. Excuse me. So import, next, finish. Okay. So let's make a bit more space. So here we are again. Hopefully it will work now. If not, then we can knock on Bill Gates's door and claim our money back. So first the input y range, so the dependent variable log staff n. Good. Now our independent variable, so log population. We want our residuals plot, we want a line fit plot. So now let's hope. Okay, so now this may sound like a funny class, but I will do it one last time. And now I will hope that now Excel has this one sheet already ready and it will somehow want to use it. Or otherwise, it might be that there is some problem somewhere, but there shouldn't be. So again, so we have the data ready again. Now we will try one small trick, and that we will copy all the data into a new sheet. Take just the values, and we will see if maybe our Excel is somehow annoyed. And you know what? I will first save the file on my desktop in order to make sure that there is no problem with that the file hasn't been saved. So now we want to perform the analysis again. Now this may be very instructive for you because you see that it's not only you who is struggling with analysis in Excel, that work with software quite often results in some problems. And I will first try to do it without the plot, just in case there was some problem. And then we will try it with plots as well. And here we are. So this is the output without plot. And let's interpret it first before it falls down again. So this list of results basically contains a lot of very useful information. And for us, the most important pieces will be the following, and you will already know the numbers from the R analysis, which we have done a couple of minutes ago. So first, here we have the R squared of our model, so 0.57, exactly the same number as we had in R. So this is the predictive power of our model if we want. So the amount of variation in dependent variable our model explains, or the share of variation in the dependent variable. Perhaps more importantly, we want to get our A and B coefficients estimates, right? So as in R, these are minus 2.37 for the intercept, the coefficient, and for the independent variable, this is 0.58. Again, this is, if I remember it correctly, exactly the same number as we had here, indeed. So this is our B coefficient, so the slope of the line. Now we can check also that the standard errors here are the same, 0.31 and 0.044. And the same holds for the t statistics, minus 7.6 and 13, right? And we get somewhat different numbers for the p-value, so for the probability that the intercept or the slope are 0. But this is only due to different reporting of numbers that are extremely close to 0, because if you look at these numbers, they are indeed basically 0, although they, technically speaking, can never be exactly 0, because we are in probabilistic world and there is always a small chance that weird things happen, things that are not captured in our model. So let us now try the analysis again, but this time also with the graph. So we have our data, and now let's see. Okay, our Excel does not like graphs, so it seems that for today I will not be able to show them to you. Or I give it one very, very last try, and then I promise I will leave you. So our Y range, our X range, and now let's try only the line fits plot. Okay, so there is some problem somewhere. So what you would see, or what you should see if my Excel worked today, would be two, in fact, quite ugly graphs that would be much uglier than the one produced here by R, but basically they would give you the same information. Okay, so this is it for today. Try it with your Excel. I'm sure it will work. It worked for me previously when I tried it for the first time, so it should work for you as well. So this is it, and see you next week.